So unfortunately, this is not the lesson where I get to show you the easy way, the fundamental theorem of calculus. That's coming next. But before we dive into that in section 4.4, we're going to take a look at properties of definite integrals that we'll use this lesson and throughout the rest of integration. The first is, if I'm integrating something from a to a, so from some value to itself, it would make sense that the answer is 0. Makes sense that the answer is 0 because we're finding the area of a region that has a width of 0. So of course the area is going to be 0. The other one says, hey, if you want to integrate from a to b, but notice these guys are in the wrong order, so I'm integrating in the wrong direction, all I have to do is negate it to change the order of this. So if my limits of integration are in the wrong order, I'm going to change it by making it the negative integration in the right order. So let's take a look at two super easy examples. The first one says, from pi to pi of sine x dx. So I could have put anything I wanted here, because from pi to pi, or 1 to 1, or 9 to 9, it's 0 every single time. The other one says, find the integral from 0, or so from 3 to 0. So we actually did this question before. And we looked at graphing this. It would have started at 2, and then moved up to here. So I ended up with the trapezoid. I don't know if you remember this from our earlier example. This was 2, this was 5, this was 3. So I said the area here would be 1/2 times 3 times 2 plus 5. And that ended up to be 10.5. So this is saying find the integral from 3 to 0. So from 3 to 0, I'm going to find the integral, the negative integral from 0 to 3. And from 0 to 3, I know the answer is 10.5, so my answer is negative 10.5. Another property that we use quite often, especially now when we're still using area for a lot of things, is essentially that it's saying we can take a larger region and divide it into parts and find the area of each region and then just add them together. So for this particular example, it maybe doesn't really make sense to do that. But let's say I had a picture that had a rectangle till I got to 5, and then from 5 to 8, I had a triangle. Well, it would make perfect sense for me to integrate this from 0 to 5 and from 5 to 8, because those are two separate shapes and I could find the area of each shape. So here's an example where we might use that property. That property for absolute value of x, we all know what the absolute value of x looks like. It's a v, and obviously I'm finding the area beneath the curve. So essentially I'm finding the area from -1 to 0, and then from 0 to 1, and of course I know that those are the same on the left and the right, so really I could have just taken 2 times the area from -1 to 0, but I went ahead and showed it as the two separate parts, the area of each triangle, 1/2 times base times height, and that answer ended up being 1. Some other properties, these should look super familiar because we looked at these for indefinite integrals. It's the same exact property for definite. If I've got a constant on the inside, it's okay to move it to the outside. If I have two separate functions, integrate them as two separate functions. So let's take a look at this question. I really like questions like this because they require us to actually know the properties. So notice what I'm trying to do is I'm trying to find the integral from 1 to 3, the definite integral from 1 to 3, of -x squared plus 4x minus 3. And instead of using the limit process or, graphing it and finding the area underneath, I'm going to use this information that's given to me. If you'll notice, these are values that I can just add or subtract. So the first thing I want to do is break it down into 3 parts: -x squared, positive 4x, and -3. And notice that's what I've done here. This one I put the minus out front, and that's okay. My next step would be simplify each one. Let's take this negative and move it to the outside. Let's take this 4 and move it to the outside, and let's take this 3 and move it to the outside. Because now it more closely matches what I have up here. My only difference here is this guy. I have the integral from 3 to 1 of x dx is negative 4. But I want to know what's the integral from 1 to 3. Well, if I switch the order of the limits of integration, I need to make it negative. So negative integral from 1 to 3 of x dx is still negative 4. So the positive integral from 1 to 3, whoops, wow, let me just, I don't even know what that was. The positive integral from 1 to 3 of x dx would be positive 4. So that's what I'm going to do now, is I'm going to plug things in. And so I get a negative and then 26 thirds, because that's all of this is equal to 26 thirds. And then plus 4 times 4, all of this guy is equal to 4. And then minus 3 times all of this guy is equal to 2. From there, just algebra, you guessed it. So negative 26 thirds plus 16 minus 6 gives me a final answer of 4 thirds.